I'm building an Astromech droid, but I'm not building R2-D2. Why? Well, I figured there's enough R2s out there, and there's another Astromech droid that only some fans remember the name of that crops up again and again and again. He's become a bit of a star in the recent Mandalorian series, R5-D4. So I'm building an R5 droid, likely R5-D4, but how am I going to do that? I decided I would completely design and build it from scratch. But why do I want to do that? There are existing community-made models out there and some great plans from people like Michael Badley who make 3D printing and building a droid very accessible for a lot of people. Why wouldn't I use those? Well, I wanted to test my own modelling know-how, and I also figured I could build it in a way that was a bit more flexible about the materials being used, so I could use less 3D printing filament in the process if possible. It would also mean the full control and ability to design and redesign any features I wanted. I found some plans on astromech.net. There's a couple of different variants, Legacy and Revised. I recommend going with the revised ones if you're building one of these. Mine is probably somewhere in the middle. I found a blueprint for the Astromech body and also R5's head, and I decided the head would be the best starting point. At least then if I got bored or lazy, I'd have a cool droid head that I could put on my car like an absolute nerd. I spent about 3 weeks 3D modelling before I finished the first draft of the full droid. And I decided to split the head up into pieces that would be glued together with little tab inserts so that I could build the head up like a cake. And then it was time to 3D print. Here you can see the 4 lower segments that get glued together at the base of the head. The orange tab sticking up will join the bottom layer to the next layer above it, and the green bow tabs will pull the pieces together so it's not just relying on a glue contact. Next you can see the full layer all together and the tabs in place for the next one. And you can see me reusing the bow joints. I went through about 20 nitrile gloves here, as you can see. The glue would stick to them just as well as to the head. Here you can see the orange inserts for the sides. That's for the little greebly sections at the back and the sides. And you can see I've made little tabs for the next layer and also little registration marks so that everything lines up really nicely. For the top section, it's a similar thing of being tabbed together, but in the center, when I hold it up to the light, you can see that there's a central puck that everything glues onto. One thing that I'd recommend is that when you're printing the top pieces, that you print them standing on end rather than flat down on a build plate. That's because the layer lines are really obvious when they're flat down, and there becomes a very staggered staircase effect. So if you leave it standing upright, it has a much better finish, and it'll save you a lot of time sanding and filling later. Now that everything was assembled and the full head was all glued up, it was time to start finishing on the surface a bit. So I used my rotary sander here, and make sure you wear a mask and gloves and all the healthcare stuff basically, because it's going to generate a lot of dust, which is not good for you. I basically took a lot of quick passes here with a fairly rough grit. I think it might have been like 80 or 100 grit sandpaper here, but I didn't spend any time too much in one area. I did cause a little bit of melting with friction in one small area, but yeah, you just got to make sure you keep moving all the time and don't stop in any place for too long. Next I used some filler. This was Liquitex modelling paste, and I could use a bit of this basically to fill in any of the seams along the head. Here you can see me using just a wooden stick, basically just smear it into the grooves anywhere where there's joints from one layer to the next. And yeah, you can see there's quite deep gouges there just from where the head doesn't perfectly mesh together. And yeah, you can just see me pushing it into any of the grooves and any of the areas where the tabs might have poked through. Once that initial pass was done, you could see that on the top the layer lines are quite thick basically and obvious, so I just had to smear it in a lot more. And yeah, this is basically before sanding. Just you can see how rough it is. It's basically just painted on very thickly. Next you can see me taking some isopropyl alcohol. I'm basically mixing that with some of the Liquitex filler paste, and together the two of those make a slightly less thick filler paste. Once I've mixed that together, then I can use that with a paintbrush to paint it all over the surface of the head. So that goes into the grooves on the top and on the sides and the base, and basically all over the outer surface. Once I'd taken that and sanded it a lot more, I took it outside and I decided to use another filler spray. This is a polyfiller one that I had just randomly lying in my shed, so I took it and decided to give that another coat around. Underneath you can actually see there was a grey coat also. That was another filler primer spray that I put over it and sanded also. So yeah, lots of layers of spraying and sanding and spraying and sanding and spraying and sanding. And yeah, pretty much any 3D print has the same process here for this. As a close-up here, you can see how much of this filler spray I used. I basically used a full can on this head just because I wanted that to be one of the main bits. And once that was dried and sanded, I took another coat of the grey filler primer. And you can see this is just going on a lot smoother and a lot less thickly than the previous fillers. And once that was dry, I gave it another kind of a wet sand. So I used a few different grades of sandpaper and wet sanded it at a higher threshold, and it basically just smoothed everything out quite nicely. You can see on the surface there is some imperfections, but they don't look like 3D print lines, which is the main thing. Once I was finished with all the sanding, it was time to give it the final white coats. So I probably gave it maybe 2 or 3 coats of this white spray. This is just a matte white finish, and I can potentially clear coat this later if I want to have a nice shinier finish, but for now I'm pretty happy with the matte finish. For the neck ring, I printed out a bunch of parts flat down on the bed and then assembled each of them. So you can see each part was individually printed and then glued together. I left one end open so that I could stretch it around the base of the ring and then it would slot over the head. Next you can see me choosing some shiny tape here that's going to go underneath the neck ladder. And yeah, you can see once I slid it over the head, it fit in reasonably well. It wasn't perfect, I would say, so I might come back and redo this neck ladder at some point. Yeah, you can see this is just a roll of this reflective tape that kind of looks like the engine turned metal that is on the real one. But I'm not 100% happy with it, so I think I'll come back and revisit that at a later point. Here you can see I've got the eyes and the side slot details. And yeah, I just take my airbrush and give it a quick coat of, I think I gave it a primer filler first, and then I just give it a black coat, and then follow that up with a silver coat after that. Next was the design of the head flap mechanisms. So you can see here I'm just using some 9-gram servo motors. I went for the ones with metal gears just because they're a bit more reliable, I think, in the long run. And you can see here I went through a couple of prototypes. The first one just had a push rod basically directly connecting the servo right onto the flap, and it had a single arm. And then the second one, as you can see here, is a bit more complicated and it's got built-in springs. And that essentially means that if somebody tries to force the flap closed or open, it doesn't actually interact with the servo at all. It just means that the springs absorb that shock, and it means that the servos can still push the flap open and close, as you can see here. I'm just doing a quick demo there with a potentiometer and an Arduino, and it can basically just absorb impact. So if somebody tries to do something, it won't damage the servo or drive voltage backwards anywhere. And yeah, I was pretty happy with my design there because I'd seen some servo saver mechanisms before for R2 heads, and that definitely gave me the idea, but I haven't seen anything quite like the design that I came up with here, and I haven't seen any for an R5, so yeah, I'm sure they exist out there for somebody, but yeah, I was pretty happy with this design. And you can see this is basically all the parts that you need to print one of the head flap mechanisms. There's a couple of screws that basically attach the flap, so if I ever need to replace any parts, it should be pretty quick to swap these out. And you can see here it's got I used the springs from some ballpoint pens just to use for the servo saver mechanism. Next is on to the eyes and getting them lit up. So you can see here I actually added some threaded sections onto each of the eyes and all the greeblies there. So that just means that I can just clamp this onto it, so it just pops into the front and it's clamped in from the back once it screws on. The orange section you can see here is some LED strips basically that I've chopped up into pieces, and it just means that everything's very modular, so if any LED goes dead at any point I can very easily just unplug the connectors at the back and pop in a new one. And it's very easy to code also because it's an addressable LED just like any LED strip. Here you can see one of the top eyepieces is the same thing, and it's got the same size connection at the back, so if I ever need to swap any of these out, it's all the same thing. Once all of the eyes are installed, you can see I just need to pop in all of the bulbs, and that's a very easy connection then, because it's only power, ground and data then to control all of these lights. When I'm done with all of the installation for this, I think I'll probably add in like a dab of hot glue just to secure all of these in place, and it just means that I can swap them out easily. And now we're nearing the end of the video. I'd love it if you'd consider liking and subscribing. My channel is just starting out, so it'd be a great help and it motivates me to keep making these videos. And without further ado, it's time for the reveal. Here you can see I've hooked up some of the servo motors just in some small sequence. I didn't hook them all up for this particular test, but yeah, you can see now that I've got my controller from my previous build. If you want some information on that, you can see it in my previous video. Here you can see me sending a value from the controller, so once I push that blue button, it sends whatever value I have in that middle potentiometer. So you can see you can open and close, and I can change to a different servo, select that in the menu, and then, well, not quite send yet, but change the value and then press and send. So that's about 3/4 of the way and fully open, and then all the way back down to closed. The next video will likely be on making the foot drives and the legs of the droid. So subscribe to see that, and thanks for watching.